Today we're going to do a bit of analysis and introduce moles and a bit of chemical equations, and we're going to go to our old favourites, the tablets. I've got a variety of them here, so I've got that one and I've got that one and that one and that one. You can use any of these effervescent tablets you can get them from all major supermarkets. They're quite cheap to use. And what you're also going to mass of a tablet. Now, I will make the assumption that the masses vary even among the tablets inside this packet, so I'm going to weigh a load of them and we're going to get an average mass. $19.20 average mass now. Okay, I took these numbers. These are the numbers we got from just weighing those tablets. So it's 20 tablets, and I stuck them into a spreadsheet into Excel, and that's what I came up with. Now, in Excel, which was 3.64 grams up to the heaviest 3.80 grams. Then I used Excel, because it's absolutely fantastic for this, to calculate the average or the mean. Okay, so that's given me the mean, which works out 3.72. So there was a couple in the middle there that were exactly average. Then I got it to find the modal answer. The modal is the most popular, okay, what there were the most of. And the median, which is in the middle, it's between those two, and because it is between two numbers, 3.71 and 3.72, it's 3.715, and the range is the difference between the lightest and the heaviest, which is 0.16 grams. So just doing this, nice little bit of data analysis, we know what the average is, that they are probably aiming for 3.72 grams. So what we'll assume is each tablet is 3.72 grams. Some will be heavier, some will be lighter, but that's what we're going to use as our average for the experiment. Okay, for the next step you need a container of water. Now your funnels are about this big, and if you put the funnel in it just about covers it, but being plastic they do float around a bit, and you will have a measuring cylinder. So fill the measuring cylinder up with water so there's no air, put your hand over the end and you can do that. So the measuring cylinder is now upside down, completely full of water. Now obviously if you let go, all the water falls out. So you need to make sure that the water stays in. And this is the fiddly bit. So here's how I do it. You need a bucket obviously, or something to put it in. Put it on like that so the funnel is inside the end of the measuring cylinder. Stand it up. Now I have the advantage that I have clamp stands and not enough hands. So let's just bring that across, open up the clamp stand. I'm not holding it tight, I'm just still can move around. So what I've got now is a measuring cylinder full of water. Now I need to dry my tablet there is going to go underneath the funnel. So this is the fiddly bit, because when they go into water they start to fizz, and we want to capture the gas that's given off. So as you can see there, the gas is starting to fill up the measuring cylinder. So like this we can measure exactly how much gas comes out of the tablet and ends up being captured in the measuring cylinder. So let's wait for a while and see what happens. Okay, a few minutes later and it seems to have stopped fizzing. So what I'm going to try and do is turn the camera upside down. So excuse me if it gets a little bit juddery. I'll just take the camera off the mount and untangle all the wires. there we are, the right way up, and we want it upside down because upside down should let us read the numbers. And if you can see there, there's 20, so it's between 10, 15, 20, 21, 22, so there's 22 centimetres cubed of carbon dioxide have been captured there. So that one tablet gave us 22 centimetres cubed of carbon dioxide. What I'm do now is repeat that for all 20 tablets, which is really boring to look at, but I'm going to set them up and run it for 20 tablets and see what we come up with. Right, I'll see you in a little while. It's the centimetres cubed of carbon dioxide that we actually got for each tablet. So starting with 22. Okay, so what I'm going to do now is I'm going to make a spreadsheet and I'm going to stick these numbers into the spreadsheet, but I'm going to show you what I've actually done in the spreadsheet first, to how these things work. So I'm going to put 20 numbers in, and the 20 numbers are going to be in those 20 cells. Okay, so this is column B, you can't see the top, but that's B7, B8, B9, and I've numbered them down the edge just to make life easier. And on Excel there's a really cool way of numbering. So if I delete all the numbers, so the first row is going to be 1, next one is 2, next one's 3. I could type them all in, which takes ages, or highlight the 3 numbers, see the little cube just there, grab that cube, left mouse, fill down, and there's all our numbers. So this square, I've told it to do an average of B5 to B34. So just move the camera up slightly so you can see that. So there we are, average B5 to B34. Now you can find these in the functions taskbar, or you can type them in. And it's good to type them in because you'll learn them. So if I start putting the numbers in, this is the amount of gas, 22. So the average of 22 is 22. 20. And it's calculating average as we're going on. I've told it to keep it all to 2 decimal places. Let's just cut down a little bit and see all the numbers as they go in, because it's really exciting. There we go, so 11, 24, so 12 is 20, and then 19, 26, 22, 23, 21, 20, 22, 20. Okay, so calculate the average, so calculated the average, 21.95, and the range, the difference between the largest and the smallest. We've got a bit of a problem here though, is because these numbers are in random order, and the range is the difference between the largest and the smallest, so we need to sort those numbers. So if I highlight all the numbers, and I'm going to have to move this up slightly, and you've got a button there that says sort. Continue with the current selection because I just want to sort those, and I want to sort it on cell value smallest to largest. So I put smallest at the top, largest at the bottom. Same numbers, so the range is 7. That's the difference between the largest and the smallest. Now if we go back to our numbers, it's much easier to sort now. The mode, I've put above it the most popular, because I always forget which one's mode and median. So most popular, let's look at the numbers. There's 2 19s, 3, 4 20s. 20's the most popular. So the modal is 20 centimetres cubed. That's the most popular amount of gas. And the median is the middle one. The middle is between these two. So the median is 22. Okay, so now we've got an average or mean, the mode, median and the range. So this one's got a much bigger range than on the other one. Okay, so what we're going to do with this, we're going to work out the percentage of calcium carbonate in the tablet. Calcium carbonate is the stuff that makes the gas. But to do that, we need to do an equation. So calcium carbonate is CaCO3. Now, we're adding something to it, but first off, I've got to make that subscript plus hydrochloric acid, which is HC small l, hydrogen and chlorine joined together. That gives us, so it's a base plus an acid, or acid plus base, always gives you a salt. So the salt is calcium chloride, and that is 2 of them. So that's the salt, acid plus base, salt plus water, plus H2O. And the bit we're interested in, acid plus carbonate, there's your carbonate, will give you salt plus water plus carbon dioxide plus CO2. Now, that means that we're going to, for every one of them, we get one of them. But obviously that's heavier because that's got an extra oxygen and a calcium stuck on it. But this is what we're going to go through in the lesson. Now, to finish this off, to balance this, if you look here, we'll just highlight, you've got 2 chlorines and 2 hydrogens. Now, whatever's on this side must equal what's on that side. 1 calcium, that's fine. 1 carbon, fine. 1, 2, 3 oxygens, 1, 2, 3 oxygens. So we're short of hydrogen and chlorine on this side. And we need an extra one, so we need a 2 there. That balances it up. That's a balanced symbol equation. But what we're interested in is the calcium carbonate and the carbon dioxide. So what I'm going to do is get rid of this bit and this bit. It's a 1-to-1 ratio. 1 calcium carbonate gives us 1 carbon dioxide. So what you will need is access to your periodic table. Okay, and that's going to be the lesson.